Warm, welcoming music begins and fades into the background.
Hey everyone, and welcome to our statistics journey. We're so excited you're here with us, and a huge thank you goes to Dr. Abdulkareem Iblasi for expertly directing this program to give you some really powerful new tools. You know, we're going to start things off not with a bunch of formulas, but with a simple and true story.
It's a story about a woman, a simple cup of tea, and an idea so brilliant it literally changed science forever. And I know, it might seem a little basic, but trust me, it holds the key to the kind of thinking you're going to use every single day in healthcare, whether you're looking at a new treatment or making sense of patient data.
See the logic in this little story? It's the foundation for everything we're going to do. We'll be digging into how to test a claim and how you can tell the difference between a real, meaningful effect and something that's just random chance. And these are the exact skills you'll soon be putting to work with powerful tools like Excel, SPSS, and R. Oh, and just a quick heads up. Think of this explainer as your personal study buddy. It's here to give you some extra support and really help these ideas sink in. Of course, it's not a replacement for our live sessions or your assignments, but it's one more tool in your toolkit to help you succeed.
All right, with that said, let's get right to our story.
I want you to picture this. It's a beautiful afternoon in Cambridge, England, way back in the late 1920s. You've got a group of the university's brightest minds, scientists and their families, all gathered for afternoon tea in a gorgeous garden. A totally classic English scene, right?
So in the middle of all the conversation, a woman named Muriel Bristol says something that sounds, well, a little odd. She insists that she can tell, just by the taste of her tea, whether the milk was poured into the cup before the tea or if the tea was poured in first. As you can imagine, the other scientists kind of chuckled and dismissed it. It just sounded like nonsense.
But one person there didn't laugh. His name was Ronald A. Fisher, an absolute genius mathematician who would go on to become the father of modern statistics. And where everyone else saw a silly argument, he saw a perfect scientific question. His curiosity was sparked, and he just said, "Let us test the proposition."
So how in the world do you design a real experiment right there on the spot? Well, this is the really cool part. This is where a simple tea party becomes a landmark moment for science. Fisher's plan was just beautiful in its simplicity. He got 8 cups of tea. For 4 of them, he poured the milk in first. For the other 4, he poured the tea in first. But here's the crucial part. He presented them to Muriel in a completely random order. That randomization was key. It meant she couldn't rely on any pattern or clue. The only tool she had was her sense of taste. Now, before we get to the result, here's the million-dollar question that Fisher was already thinking about. How do we know if she's right because she actually has this ability, or if she just got lucky? This, right here, is the absolute core of statistics, separating a real skill from pure random chance.
So let's really get into that question. If she were just guessing randomly, what are the chances she could get all 8 cups perfectly right? Take a second to think about it. It's not as simple as it sounds. There are a lot of ways you could choose 4 milk first cups from a set of 8.
Fisher, being the math whiz he was, already did the calculation. The odds of her guessing all 8 cups correctly just by pure luck, a measly 1 in 70. That's a tiny 1.4% probability. So while it's technically possible she could guess her way to a perfect score, it is incredibly unlikely. So what happened? Muriel Bristol sat down, she tasted each of the 8 cups, and to the absolute amazement of everyone there, she correctly identified every single one. This is so much more than just a fun story about tea. It perfectly illustrates the core logic behind all scientific testing. It gives us a really structured way to make decisions, especially when we're dealing with uncertainty.
Fisher actually formalized this with 2 competing ideas. The first one is called the null hypothesis. Think of this as the default or nothing special is happening assumption. In this case, it's that she's just guessing. The second idea is the alternative hypothesis, which is what we're actually curious about, the idea that she can, in fact, tell the difference.
So because the result, getting a perfect score, was so incredibly unlikely to happen just by chance, remember those 1 in 70 odds, it gave Fisher really powerful evidence to reject the just guessing idea. By rejecting that null hypothesis, he could confidently say that the evidence supported the alternative. She genuinely had the ability she claimed.
You know, a great way to think about this is to use a courtroom analogy. The null hypothesis is like the presumption of innocence. We start by assuming there's no effect. The person is innocent. The data we collect is the evidence, and if that evidence is strong enough, if it's beyond a reasonable doubt, we reject the idea of innocence and deliver a guilty verdict. If not, we fail to reject it, and the verdict is not guilty. So what does a tea party from the 1920s have to do with your work in healthcare today? Well, everything. This is the exact same logic we use in every clinical trial. Is this new drug actually better than a placebo, or are the good results just a fluke? Does this new health intervention really improve patient outcomes, or is it just random noise? Statistics is the tool that empowers you to answer these questions and make confident, evidence-based decisions that can change lives.
As we move forward together, I really want to encourage you to see statistics not as some dreaded math class, but as a series of fascinating logic puzzles. Try to enjoy the stories that the data tells us, because mastering this way of thinking is what's going to make you a truly exceptional clinician and leader in your field.
And of course, if you have any questions at all, please do not hesitate to use the course Q&A or the discussion board. Asking questions is one of the best ways we learn. And I promise you, if you're wondering about something, someone else is too. Your questions really do help everyone.
Thanks so much for joining me for this first story. I really hope you enjoyed it, and we are looking forward to seeing you in class.